Okay, so let's start with finding the domain. We're supposed to find the domain of this function. And so with domains, you can really have any number that doesn't cause you to divide by 0 or take a square root of a negative. So there's one chance of dividing by 0 here. We want to exclude x equals 1. So the domain of this function would be negative infinity, as small of a number you can think of, comma 1, and union 1 to infinity. I'm saying, look, lowest number you can have, we don't reach it, negative infinity, as low as you want to go. And any number up until 1 is fine, but then when you get to actually 1, you've got to stop, and that's why I use parentheses, because parentheses means you can't equal exactly 1. And then once you get to 1, you can keep going towards positive infinity. So there's our domain. And so to use limits to describe the behavior, what they want you to do is say, hey, the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right, because 1 is that number that's not in our domain. So the limit as x approaches 1 from the left. So to describe that behavior, you could go on Desmos.com and graph it and tell me what are the y values as x gets closer and closer to 1, but from the left, like 0.9. Or you could do it this way. You could numerically evaluate that limit. Plug in x equals 0.9. That's a number slightly to the left of 1, isn't it? So with my handy dandy calculator, I'm going to do 0.9 minus 1. I'm going to do the denominator first. So it's the numerator, negative 3, divided by the denominator, so that's 30. So let's evaluate the limit by getting even closer, 0.99. If I plug in 0.99 in the denominator and subtract it by 1, that's what my denominator equals. So negative 3 divided by that, I'll just remember it's positive 300. And what do you think is going to happen if we were to plug in 0.999? The pattern continues, right? So as x gets infinitely close to 1, but from the left, we have positive values that never stop increasing. So this limit is positive infinity. And then you want to do the same thing, except the limit as x approaches 1 from the right. So you could do this numerically. Pick a number that's slightly bigger than 1 this time. So x equals 1.1. If I plug in 1.1 in the denominator, I've got 1.1 minus 1 makes 0.1. So it's negative 3 divided by 0.1. So that's negative 30. And then if you're not sure of what the limit's going to be, plug in another number that's even closer to 1. Because limits are the y values as we get closer and closer to a certain x value. But this is what you'd get if you plug those in. So we just evaluate numerically this limit. As x approaches 1 from the right, we plugged in a number slightly bigger than 1. We got y values that never stop decreasing, so this is negative infinity. Okay? So that's what they want you to do for these problems. Tell us the domain, and then describe the behavior around those vertical asymptotes that are happening. Okay, so I'll do the same thing for this one, except this time I have two numbers to exclude. The first number on our interval notation train is negative 1. Get off at the station at negative 1, and get back on once you pass negative 1, then stop when you get to positive 1. We also have to exclude positive 1 because that would also cause a divide by 0 problem. Okay, so there's two numbers you got to evaluate this time. You want to evaluate the limit as x approaches negative 1, and you want to do that both from the left and from the right. Okay. Now, if you don't want to do it numerically, if that takes you too long, let's go to desmos.com/calculate 2 over x squared minus 1. So 2 over x squared minus 1. So here's our graph. And the first limit we said was right here at x equals negative 1. So the limit as x approaches negative 1 coming from the left side, the y values are going higher and higher, and they never stop increasing. So the limit as x approaches negative 1 from the left is positive infinity. But the limit as x approaches negative 1 coming from the right side, these values are going towards negative infinity. And do the same thing for positive 1. If I try to approach positive 1 coming from the left, start on y equals negative 2, negative 3, negative 4, negative 5, never stops decreasing. So the limit as x approaches 1 from the left is negative infinity, and then it's positive infinity if you approach it from the right.